The following is the diagram shows a cross section of a cylindrical milk tank of diameter 2 meters. Said change that to 200 centimeters. Next thing, the length of the tank is 4 meters. Okay, so basically it's a cylinder and it's going back 4 meters. We won't worry about that 4 meters just yet. Okay. The length of the tank, the depth of the milk in the tank is 40 centimeters. Calculate the nearest litre, the volume of milk in the tank. Well, guys, to get the volume of the milk in the tank, here's what you need to do first and foremost. You need to find out what is the area of the face of milk. So you need to find out this area here. Once you find out what this area is here, volume equals area multiplied by length. And the length obviously is your 4 meters. Okay. Now let's go back to solving out the area of this. Okay. Now what I can do is I'm going to draw the center of the circle. Now draw the center of the circle. I'm going to join them like so. Each one of these is a radius. It's a radius of 100 centimeters. That's 100. That's 100. And all the way down to the bottom is also 100. Okay, that's 100 as well. Okay. Okay. 100.
You just run it.
100 and 100. Okay, guys. Now, lads, what I know about this is it's 40 centimeters from here to here, which makes it 60 from there to there. I now have a right angled triangle. Okay, so in effect, I have a right angled triangle, and what I can do is I can do 100 is the hypotenuse, 60 is the other side. Do Pythagoras' theorem, find out what is the other side. It's going to be 100 squared equals 60 squared plus x squared. When I do this, alright, what's going to happen is I'm going to get x squared equals x equals 80 when I solve that. So everybody know how to solve it? Bring the 60 out the other side, take it away, square root it. It's going to end up to be 80. Okay? Now that we know that's 80, what happens next is, just going to rub this out. We now know the bottom is 80 and the perpendicular height of this triangle is 60. So if I was to get the area of this triangle, so my plan is this. If I was to join this back to the center, like shown, if I get the area of the sector minus the area of the triangle, I find out what the shaded region is, okay? So area of sector minus area of triangle. Rory? Area of sector minus area of triangle, okay? So, first of all, write down the area of the sector. Area of the sector is going to be, area of the sector is of radius 100, the sector is. And we have to figure out the angle. We haven't got the angle yet, okay? Now to figure out the angle, what I'm going to do is I'm going to figure out what is the angle in here. Oh, sorry, I know that's 80. Okay, what does that mean about the full length along the bottom? 160, okay? And what I'm going to do next is I'm going to sine inverse this. I had the 160 originally, didn't I? That is the, cos inverse. That is the adjacent and the hypotenuse. So cos, we'll call it x. Cos x equals 60 over 100. Can somebody cos inverse that for me? $53.13. Okay, guys. X equals 53.13. What does that mean about twice that angle? 106 point. Now, problem there is it's degrees, not radians. How do you convert it into radians? Divide by 180 and add a pi onto the answer, okay? So what's that divided by 180?
0.59.
So it's actually 0.59. That's actually quite a nice number.
Yeah, 0.59.
0.59, okay?
Oh, we didn't have pi.
And we didn't have the pi's, right, so 0.59 pi. Now guys, I can use a half r squared theta. And what we're going to get here is a half, so we put this in, a half 100 squared times theta, which is 0.59 pi. What do we get? Put it in terms of decimals, not pi, if possible.
2950 pi. Oh wait. 9267.69.
9267.698. 0.698.
Can't use the pi in a calculator.
No. You use the standard pi. 0.5 multiplied by 100 squared. Multiplied by 0.59.
Just put the pi represent 180.
That is the measurement in radians. The measurement of the angle in radians is 0.59 pi.
The square, not the inside the bracket.
Sorry?
The square, the inside the bracket.
It doesn't make a difference for this one. Okay? And what we get here is 2950 pi, which is the same thing as 9200. So Hugo is very much correct there. Okay? Now guys, what happens next is we're going to get the area of the triangle. Okay? Now the area of the triangle, just 1 second. The area of the triangle is 180. Twice 80, which is 160. The perpendicular height was 60. So a half base by height. So half 60 by 160 gets me what? I think it's going to be 4,800. Anybody?
Yeah.
Take them away from each other and what do we get? Because that's what remains.
.698.
Does it give me any instructions to round it up or anything like that? To nearest leader. So now here's the problem here. Nearest leader. That is centimeters squared at the moment. Okay? Because that is the area of the face. We need to now multiply that by as a 4 meters, but that means I'm multiplying by 400. So multiply that by 400 and what do we get?
1787079.2.
That one? Oh no, I didn't take it away, you're right. So what do you get?
You got 1787079.2.
Oh, what comes next?
1787079.
Yeah.
Point
2. Centimeters cubed. Now, how many centimeters cubed in 1 liter? 1 liter equals 1,000 centimeters cubed. So therefore, divide that number by 1,000 to change it back into liters.
1787.
Was it? 1787. Is that it?
.0792.
Okay. And liters. So round it off to the nearest liter. 1787 liters. Is that the answer in the back of the book?
1789 in the back of the book.
Sorry?
1789 in the back of the book.
Okay, so more than likely. Okay. Okay guys, and number 44. Diagram shows a sector P and centre O and radius 6. AB and AC are tangent to the circle at B and C respectively, where the angle BOC equals 2 pi, where theta, with theta is in radians. The shaded area outside the circle is Q. So P is on its own and Q is on its own. Okay? And P plus Q would be the area of the full thing together. Write down the area of sector P in terms of pi. Sector P is a sector, which means it's going to follow the formula a half r squared half r squared 2 theta. Okay? So we're going to get a half r squared. Now it's a half r squared theta, but in this case we don't have theta, we have 2 theta. Okay? And it's going to be a half. Now what's r squared? Anybody? It says it here. 36. A half 36 times 2 theta, 18 theta. Okay. Next one. Find the area of the triangle OAB. Now OAB, as I said yesterday, is, I'm just joining this one here, and it's getting cut in half basically, okay? So when it's getting cut in half, so OAB is this what's happening to it, okay? It's going to be it's a right angle triangle. Why is it a right angle triangle? Can anybody tell me?
It's a tangent.
It's a tangent, okay? This is radius 6. Now, it wants me to find the area of this triangle. Now, the reason why I know to do the area is this, because I'm going to double the area to find out what is the area of the full black part here. Okay? So what I'm going to do is, I need a half base by height to do this. So OBA would look something like this if it was to rotate around. It would look something like this is 6, this is 90 degrees, and I need to find out the height. And it says in terms, the key word there is, it says in terms of tan theta. So what is tan theta? Tan theta is h over 6. H therefore is 6 tan theta. The area of this triangle is a half base times height, which is going to be a half 6 multiplied by 6 tan theta, which is going to get me 18 tan theta. Is that right? Now guys, now that that's done, 18 theta and 18 tan theta, okay, we found the area of OAB, that's done. Deduce that the area of region Q on its own is 36 tan theta minus theta. Okay, the area of the full thing in black is twice the answer I got a second ago, which is 36 tan theta. Then taken away from that, we're going to take away the sector. See the light purple? We're going to take this sector away from it, which is guys, very obvious mistake in the first part. A half of 2 is 1. It's 36 theta. Now, because this is a proof question, I got to find my answer. Sorry, 36 theta. Factorize what's in common. Why am I not allowed to take out 36 and theta? Because the tan and the theta belong together. Okay, so it's going to be 36 into tan theta minus theta. Okay, proven. Given that regions P and Q have equal areas, show that tan theta minus 2 theta equals 0. Okay, tan theta minus 2 theta equals 0. Okay, so, alright, both regions have equal areas. Okay, regions P equals region Q. So here's what happens. This here is what region, guys? P or Q? It's region Q. Okay, so Q equals 36. I'm going to multiply it back out again. 36 tan theta minus 36 theta. And this in turn says that it has to be equal to the region P. What did we say region P was again? 36 theta. Bring the 36 theta over the other side, and we're going to get 36 tan theta minus 72 theta equals 0. Factorize out 36, and you're going to get 36 bracket tan theta minus 2 theta equals 0. So 36 multiplied by this number in here is 0. What does that mean about the number in the red block? And is that what I was asked to prove? Yeah. It is, so that's it done there. Okay, next one, guys. Now, this one here, okay, I actually found this quite difficult myself, so I actually had to get a real object to to figure this one out, okay? So a real cone. So the first thing that we're going to do is write down the value of L, okay? Now L is this length here, the slant height. Now the trick is here is you're going to get mixed up with your letters. The slant height, see the way this is organised here, yeah? The slant height is actually the radius of the slant height L is actually the radius here when you fold it up. So when I fold it up, we can now see it belongs to the slant height. Is that right? So L is in fact 20. Okay? Show that R equals 10 root 2. Well, what it says is, if I know that this here is 20, if I know that this is 20, I know that H is equal, what?
They're both X.
Or both, yeah, or both, or whatever way you want to put it. Right, so they're equal to each other. Pythagoras' theorem, 20 squared equals x squared plus x squared. 400 equals 2x squared. 200 equals x squared. Square root 200, and you get 10 root 2. Okay. Now here's the next hardest part to understand is this section here that I'm going to mark in blue, or sorry, different colour than blue because blue's already used. This section I'm going to mark in purple is the arc, right? Now this arc, which is here, is actually the same as the circumference of the circle. These two are actually the same thing. Okay? So to do this, we have to figure out what theta is. I know what R is. We're going to use the formula L equals R theta. Now the problem there is, I don't know what theta is. That's the whole point of the question. But I also know this equals 2 pi R from the circumference. And the circumference, we have the radius for it, so it's going to be L equals 2 pi multiplied by 10 root 2. L equals 20 root 2 pi. Now that we know what L equals, what we're going to do is we're going to put it into the other formula over here. Okay? So L equals, now what's the radius of this one? Radius is 20, which is a completely different radius to this one here. And if that's equal to 20, then we have theta beside it. And now we know that L equals 20 root 2 pi equals 20 theta. Divide both sides by 20 and you get theta equals root 2 pi. And that's them done. Okay.